Okay, so we have this following unbalanced circuit here, and we have to find the line current, IA, IB, and IC. So we're told um, that the delta configuration is supplied by balanced line-to-line voltage of 240 volts in the positive sequence. So line-to-line, that's VAB, okay? If we start from there, that's 240, phasor 0, and we're told it's balanced, so that means VBC will be 240, phasor minus 120. This is positive sequence, so it's an ABC. And then VCA is 240, phasor minus 120 again, but then we add 360, so positive 120. Alright, so that's good. So first thing we can do is get the currents passing through here. Okay, so let's first get the phasor values. So 10 minus 5J, that should give me 11.18, phasor minus 26.56. 8 plus 6J, that should give me 10, phasor 36.89, and then 16, that's just 16 phasor 0. So now we can get IAB, BC, and ICA. IAB will be 240, phasor 0, all over 11.18, phasor minus 26.56, and that gives me 21.46, phasor 26.56 amperes. Now IBC, that will be 240, phasor minus 120, all over 16, and that's just 15, phasor minus 120. And then ICA will be 240, phasor 120, all over 10, phasor 36.89, and that's 24, phasor 83.11. And all of these are in amperes. Alright, so it looks good. Now we can use this to find the line current. So we see IA is entering. Oh yeah, we can use that formula. Like it looks something like this, VAN. We can't use this formula because it's an unbalanced circuit. You can only use this formula for balanced circuits. Anyways, so we see IA has, this is, we call this is IAB, this is IBC, and this is ICA. So IA plus ICA is equal to IAB. So IA is actually equal to IAB minus ICA. IB will be equal to so IAB is entering it. So it's going to be IBC minus IAB, if I'm not mistaken. And then IC will be ICA minus IBC. Okay, I think that's right. Alright, so we pretty much just plug these in. But we have to get all of these into, we have to break them up into its real and imaginary components. So the first one, IAB, that's 19.28 plus 9.64J. IBC, that's minus 7.5. Phasor, minus 7.5. Minus 12.99J. And then ICA, that's 2.879 plus 23.83J. All right. So pretty much IA, we pretty much subtract these two, and you should get 16.401. Wait, hold on. Give me a sec. Let me double check. Nope. Wait, hold on. Let me double check quickly. Sorry. Oh, sorry. Not those two. Sorry, you subtract these two. It's IAB minus ICA. So it's 16.401 minus 14.19J, and that's 21.68. Phasor minus 41 degrees in amperes. IB is IBC minus IAB. So this minus this. So it's going to give me minus 26.78 minus 22.63J, and so that's 35. Double check the phasor value because you'll have to do the Cartesian plane for this one, because it's so if you do the phasor value, it's minus 22.63 divided by 26.78. Get the tan of that, tan inverse of that. That's 40 degrees, so that's up here. So that's 40.198. But this value, it lies somewhere here. Okay, so minus 26.78, that's here, and minus 26.63J, that's down here. So we'll have to add or subtract by 180. So what we can do is we can subtract by 180, and that gives us minus 139.0 degrees in amperes. And finally, IC, it's ICA minus IBC, and that gives us 10.379 plus 36.82J, and that gives me 38.25. Phasor 74.27 degrees in amperes. Okay, and this is IC, and those are your answers.